get it in sensitive tissues, like eyes.
Well, really, it comes up that sensitive, you know, man, right?
Right.
I think
Yep.
the beginning of the new crop of poison ivy, too.
You must have came down here some other way. I think we got to go over the other side there.
Lily. Oh, he's also a botanist.
Yeah, I didn't ever have to.
This is lots of things. He graduated from MIT.
Yay!
Massachusetts Institute of Technology.
That and bucket tools get me some coffee. Okay, let's see if we can work our way down.
Yeah, the terrain has changed somewhat.
There we go. You do know what BSMS and PhD stand for, I presume. The BS one is obvious. MS is more of the same, and PhD is piled higher and deeper.
I can swing it too with the best of them.
Now this rock looks very similar, somewhat similar to the rock that we've had at the other place. Except you can see the banding in this one. The cleavage is running this way. It's splitting in this direction. Obviously. If I turn this though, you can see striping running along in this direction, and it's cutting across the cleavage. You can see when the angle changes, the direction of the striping changes. That is the original sedimentary bedding of this rock, and you can see that it does have very obvious bedding. Once you know what to look for, it wouldn't have been obvious had you not taken my course. But now, of course, it's very obvious. And as a matter of fact, when we get back, you'll be able to see this. I've got samples of this sitting in the room as well. This is the Urbana formation. And in this particular case, well, obviously it's named for the town of Urbana in western Montgomery County. The formation bit requires a bit of explanation. The other one was the Igemsville phyllite. They actually gave it a rock name. This one has several different rock types interlayered. Some of this, I neglected to bring along my acid this time, but you've seen how it works. Imagine I have a bottle of acid here and the rock in my hand, and if I put the acid on some of those layers, they fizz very nicely, and some of the layers do not. The layers that don't fizz are low-grade metamorphic rocks, probably best described as a phyllite again. The ones that fizz are actually an impure limestone. And that's what, of course, is making it fizz. So in this particular case, the sediments varied from time to time. And that is typical of the shallow water stuff, because under shallow conditions, the weather affects very greatly exactly what is being deposited at any given moment. Because there are limestone layers here, it would be conceivable that you could find a fossil in it. As I've told you, nobody has. So I don't hold out much hope. Now, some of the rocks over here, see if I can make a fossil here without getting too wet and without falling in. What I'm looking for here is a place where I can find the bedding in place in the rock, which isn't easy. I know that there are places here where that can be done. here's a piece I actually want to take back to the lab and put it in the collection. Let's see if I just put it right there. That's obvious enough. You can see the bedding in that very nicely, and you can see that some of the beds do have a phyllitic structure to it. They actually have the phyllite shine. And so that would be a very good one to show the illustration of bedding versus the cleavage. Okay, I can actually see some bedding here. Not very obvious though. The reason I would look for the bedding here, this is something that I didn't go over in the lecture. This is something that you do in field geology. This Sugarloaf Mountain is an anticline. It's an upfold. And the oldest rocks are the Sugarloaf Mountain quartzite that you find at the summit. We'll see that at our next stop. Now, Sugarloaf Mountain is the highest point in the Maryland Piedmont. Stands quite a bit above the rocks on either side. Why do you suppose it's the highest point in the Piedmont? Why does it stand higher than everything else around it? Anyone have any ideas? Because it's quartz. Yes, it's almost pure quartzite. And quartz, as I've stated many, many times, has hardness, physical hardness 7, and is almost indestructible for weathering. Not absolutely. In a humid tropical climate, it can go away. But by and large, in a more reasonable climate, it does not chemically react with anything. And so where the surrounding rocks keep getting worn down, they're both softer and more easily weathered. This stands up. And as I say, it's the oldest rock. And it's found in the... Now, if you look at the rocks on this side of the mountain, they dip back towards us. It slopes very steeply upward that way. I can't find a good place to demonstrate that here. I could maybe if I spent enough time, but we've got lots of stops. At the very top of the mountain, you'll get to see good bedding there, and it's just about horizontal. If you go look at the other side, it dips down the other way. Now, that of course happened when it was compressed in one of the collisions, in one of the later collisions actually. And the axial plane of the fold is perpendicular to the greatest pressure, which means the axial plane generally dips very, very steeply because the biggest pressure is horizontal from Africa banging in. And the axial plane also divides the anticline into two symmetrical halves. If the axial plane is vertical, then you have a symmetrical anticline. If the axial plane tilts, then the rocks, of course, tilt. Now, if you find an outcrop like this, where all you can see is the bedding and the cleavage is parallel to the axial plane. That's a clue as to the geometry of the fold. They are related. And if you measure the bedding, how steeply the bedding dips of both the axial plane, both the cleavage and the bedding, then you can get some idea of the geometry of the fold. Anyway, this is what's called a Brunton compass. When I bought it, it was about $50. I think it's a couple of $100 now. It has moving parts, obviously, like a needle. And a little lever back here where I can change the direction of north to allow for magnetic north. So I can read the actual direction of anything directly from the compass, and the correction for magnetic north is automatically made, because the needle, of course, does not point towards true north. It points towards magnetic north. And this is set for the local, what's called declination. And I can sight using the mirror to see where the needle is. I'm using this sight here to sight on something, and I can read the exact direction that I'm looking, which works out very nicely. Now, the other thing that it does is a level on there, and I can move that level. So it's just like a carpenter's level, and so I can measure the angle of dip of any plane, of a bedding plane or cleavage or whatever it is I'm looking at. So this is also good for shaving. Now, why I would be interested in that here, if you've got cleavage and bedding, if the cleavage dips at a smaller angle than the bedding, if this is bedding and this is cleavage, then this divides the fold into two even sides. So if this goes this way, that means I've got another one going that way, because that's a mirror. The plane in the middle of the mirror, the axial plane. And that means that I am on the side of an anticline going this way, a syncline going that way. If the cleavage is like this, and the bedding is at a steeper angle, that means the bedding is overturned. So I can get an indication of which direction is up just by looking at the cleavage and the bedding, unless it's really very badly deformed. If you start refolding the folds, then all bets are off. Then you can't work that. But most folds are actually, including this one, are fairly simple. They're not that complicated. So that's what you do when you go mapping in a place like this. You have your little Brunton compass with you, and you actually measure the orientation of the cleavage and the bedding for the information that you get out of it. Let's assume that I showed you, this shows the bedding very nicely here, this rock here. And so that's the indication that we're now in the Laurentian terrain. And let's see if I can make it back across without adding a new batch of water to my chute. Thank you. Okay, that'll do for here. As I'll repeat, this is the Urbana formation. And that's my, thank you. That's my rock so I don't forget it. And it shows very nicely the bedding and the cleavage. And so future classes we'll get to see this in the lab. Now we'll head up to the top of Sugarloaf Mountain, which at the moment we still can do because it is open to the public.